Hey everyone, today we're going to discuss earth retention systems. What is an earth retention system? In the US, it's commonly referred to as shoring or sheeting. It can provide temporary or permanent supportive excavations in the construction industry. It can be made up of piling, pile driving, drilling, tiebacks, anchors, dewatering, and other sorts of analysis and construction monitoring can also be included. Today in the US alone, the industry accounts for several $billions of work annually. There are many types of earth retention systems. Conventional shoring techniques in the U.S. today are driven or vibrated sheet piling, soldier pile and lagging, soil nailing with shotcrete, secant or tangent piles, structural slurry or diaphragm walls, and micropile retaining walls. There are several types of materials commonly used in the construction of these systems, but the most common are wide flange beams, steel sheet piles, and channel steel beams. When designing an earth retention system, there are many things to consider, but the primary things are the soil conditions, the temporary or permanent loading conditions, the groundwater table, and allowable deflections. We must also consider global stability. To support an earth retention system, you must provide lateral support in some way, shape, or form. This is typically provided with tieback anchors, internal bracing with struts or whalers, deadman anchors or rakers, or sometimes backfill with soil. After the wall is complete, aesthetically, we have to provide some sort of surface that is acceptable to its final use, whether it's sculpted shotcrete or uh, lagging timber or concrete or some sort of shotcrete facing. Some examples of an earth retention system. You can see on the left, top left, a sheet pile wall, and above the right, a permanent soil nail wall for the Dallas Cowboys Stadium. Some other examples include soldier beam and lagging on the bottom left, and on the right with the internal bracing with struts. And on the top left, you can see a diaphragm wall. In this photo, you can see another example of a soldier beam and lagging with tieback anchors. And on the bottom right, you can see what's called a tangent or a secant pile wall, creating a compression ring for accessing a utility shaft. Some typical equipment for sheet piling, we have vibratory or diesel hammers for advancing the piles into the ground. Some drilling equipment for drilling deep shafts or secant piles, or for installing beams for soldier beam and lagging walls. Another method we more commonly used today is called soil mixing or jet grouting, where we're injecting grout into the ground, mixing in situ soils together. A couple quick animations of sheet piling and drilled piles and driven piles, showing how the typical equipment advances tooling into the ground so that we can install these systems. Some animations of soil mixing and jet grouting. Wet soil mixing is mixing a wet grout binder in situ with the native soils and creating a relatively low strength but hard grout soilcrete. Dry soil mixing is simply the opposite. Some typical tieback equipment here, installing lateral supports. A couple photos of some batch plants where we mix up grout to inject binder into the soil. Load testing is always important for testing your lateral members and ensuring the system is performing adequately. Construction monitoring has become much more widely used and affordable, monitoring deflections on shoring walls using automatic total stations and inclinometers and piezometers to measure wall movements and groundwater table fluctuations, as well as vibration monitors for sensitive buildings and similar types of technologies. Some animations showing installation of tieback anchors or soil nails, as well as soldier beam and lagging, where the beams are placed first, and then we'll dig down in lifts and install the timber lagging. Some other methods, a lot less commonly used, but in the right application, is really the only technologies that we have for doing it. On the right, you see a diaphragm wall being installed using um, a deep slurry mixing machine called a uh, cutter. The cutter soil mixer hydromill can be referred to as a couple other things, but installing deep panels which are then pumped with concrete where we can install steel reinforcement to support a large compression ring, likely here for a tunnel boring machine. You can also see in the top left smaller photo a hydraulic grab bucket, which is a similar technology for creating these panels. Multi-axis soil mixing equipment, uh, similar to the diaphragm wall, where we're and to the wet soil mixing, where we're mixing multiple columns uh, of soil on the way down while injecting grout, creating a soilcrete, which will act as lagging between our structural members. Very effective where we have high groundwater tables and need to create cutoffs to keep excavations dry.